2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
So for those of you who aren't familiar with Drupal, Drupal is an open source content management framework. It's PHP, MySQL. It doesn't have to be MySQL, but that's usually what it runs. And it's designed for rapid development of content-rich web applications. So it is often, I mean, it is in the category of CMS, right? So WordPress, Joomla, other publishing applications fit into the same category, but Drupal is actually not a CMS. It's a framework that can be expanded and extended to be able to do more than just handling content publishing. And we have many reasons why we use this. This is not the only application, certainly, that we work with, but it is one that we focus on. And there are some reasons for this. And one is that the Drupal community is a very active and vibrant community. And so the tool itself continues to evolve. And for example, a couple of years ago, the primary issue was that big websites were more and more using Drupal. And it didn't perform. It wasn't as performant and scalable as sites like the Grammys, the White House, The Economist, The Examiner would need it to be. So the community pushed ahead in terms of solutions for performance and scalability. And now the kinds of things we're going to talk about today are also being tackled by the broader Drupal community. So we've stayed with it, and I've stayed focused on it professionally because it has grown to meet the needs that I keep having. Oops. I'm going to try not to do that, Brian. I'm really sorry. I'm hitting that. The other thing is that with every development team, you invest in a foundational skill set, right? And whatever investment you're making today will be mostly worthless 6 days from now. So one of the things that I like about Drupal is that investing the team's foundational skill set in building expertise in Drupal has enabled us to solve the kinds of problems that have come to us in a relatively fast and repeatable way. And then the other, of course, part of every website are the users, and the ability for users to control what they want to do with their web application and the publishing of their content comes out of the box with Drupal, or at least can be added by contributed modules. So far we've been able to build things that people can actually use without too much customization of the administration. A fair amount of customization of the UX, but that's a whole nother session. So we talk about big data, the term big data. This is actually what comes to mind every time that phrase comes up, and that's not who we're talking about. In this session today, and the one that will follow it, when we talk about big data, we're not actually talking about Amazon and eBay and Twitter. We will likely not solve Caterpillar's data issues with Drupal. They will not, that will probably not be part of the solution architecture. So when what we mean by big is in relation to the amount of content that Drupal is designed to manage, or the data that Drupal is designed to manage. This would translate into most PHP, MySQL applications. Right? That the things that we're doing here, we focus specifically on solutions that have Drupal at the center of them, but this would translate to many other kinds of circumstances. So when we talk about big and defining big, which is a big argument in this community, what we're talking about are the 3 V's. And this is more and more becoming the adopted way of defining what we mean by big when we talk about data. So the first is volume, and that is what I'm saying up front, right? That the amount of data and content that's being used and being presented is growing bigger than what the system is managed to maintain. We also mean velocity. This is my favorite slide of the day. So I drive a BMW F650, but when I'm on my motorcycle, I think that's actually what I'm doing. So velocity is the fact that as the web matures, more and more data has to be presented faster and faster. right? So we can present more data, but if it takes us 5 minutes to load it in order to present it, then that's not going to work. So we're increasing the volume, and we're also increasing the velocity, and we're also increasing the variety. So gone are the days in which a Drupal and other web applications are meant to publish text and images, or text and an image. Now data can be many different kinds of pieces of information, and it also can come from many different places. So we're redefining what content is, right? So content is no longer, capturing strings in a relational database, but content can be every kind of data, including, what did he call it? Oh, adjusted data. That was one of my favorite, including the adjusted data. So it can be the fields that you traditionally would think of in terms of capturing information about a process or about clients or about behaviors of people on the web. And it can also be, of course, text and images and videos and music. It's also the relationship between the content and the taxonomies that are used to create those kinds of relationships, which is big data that is, bigger even than a Drupal conversation is going to include. It uses technologies like Hadoop to be able to manage and maintain those relationships. And it also is coming from everywhere. So, originally it was feeds, and you could get a feed and publish feed content with your web application. But now you can get data from everywhere and integrate it, do interesting things with it, process it, do some math, and be able to present it as part of your web application. And the same thing is true in the reverse. You can build APIs and be able to share what you've created as a result of doing some meaningful analysis locally. So the current issues with Drupal related to being able to meet these expanding needs for content, volume, velocity, and variety is that Drupal relies on bootstrapping for its genius. And it really is the genius of Drupal. And that is that when you write code that expands the core of Drupal, every time a page loads, Drupal says, do you got anything? Do you got anything? Anybody? Anybody? Bueller, do you want to add anything? Right? So it means that it is quickly extendable to be able to interrupt at any level of the process what you need to interrupt before the very last thing it does is present the page. So you can include many different processes. You also can do processes that run in the background and then just give the blob of what you've captured during bootstrapping. So this is one thing that's great about Drupal, but it also means that bootstrapping can become a very costly process if you're going to be serving up a lot more than Drupal is meant to serve up during that process. And the other thing is because it runs usually on a MySQL database, so normalized data saved in tables means one thing at a time. There are bottlenecks in the requests, and also the traditional ways of being able to develop relationships between data and express it in a sortable, viewable kind of way means that it gets join happy. You can have, and we're going to get deep. We're going to show you some pictures of what joins can look like in the way that Drupal is traditionally architected to connect data. And then my little soapbox argument here is that one of the things about Drupal is because it's easy and it's quick and you know how to use it, you install it and you start building things. And so this breaks the rule that my computer science professor said in the first week of my first programming class ever, which is don't sit down and type pound include and start typing your code. Have some architecture of what you're planning to do and how the pieces will fit together, and then begin to create the objects that you need in order to be able to do that, right? So Drupal is predominantly, the vast majority of Drupal is functional. So there's a big cry for more object-oriented thinking, but there's not really necessary. And so there's not a lot of solution architecture usually involved in the development process. But once you get into the kinds of things we're going to talk about now, and we're going to talk about in our second session, you need solution architecture at the beginning and all the way through in order to be able to meet the challenges that are going to arise. So the other piece that is different and a change from the way that CMSs are thought about, and Drupal specifically, is the question, who is the user? So most of the way that the application and contributed code works is to meet the need of visitors and content authors. And what's presented in, even when we're presenting advertising, is about engaging with user behavior by what's being presented to someone who's visibly looking at the site. But more and more, and a lot of the focus of our development and where we want to do even more in the future is the other group of users, which are the data miners. That if you have a web application that is doing a lot of capturing of essential and important data and the relationships between that data, someone needs to see and wants to see reporting on that. And this is where Drupal literally falls down. Right? That now you start to have very, very lengthy processes in order to present something that is meaningful to the data miner using this web application as opposed to visitors. And we're going to talk about the way that Drupal usually solves problems for the increasing Vs, and then how those problems can be solved when your primary user is the data miner. So with that, we'll start talking about the future, where modularizing the architecture leads to more performant applications than you're going to do with Drupal alone for all kinds of content and the two different kinds of users. Okay.
So traditionally, Drupal requires, for any kind of a performant web app, more caching, right? Tons and tons of just cache every piece of data, cache every piece of content at every stage, at every level you possibly can. And this can get kind of unwieldy. It can, it works pretty well today for the vast majority of web applications, but as Diana was just pointing out, we have different content needs now. We have velocity, variety, and volume of data. So these things are not going to continue to work for too much longer. So for most of your web applications, you're going to have to be thinking about this great balancing act, right? Between the processing power that you have on the server side and the size of your pipe between that server and the client, user, machine, whatever that you're trying to send content to. And so the caching architecture is the low-hanging fruit in this. It's the first thing you go after. But as your application grows, the world as we see it is we have all these relationships that we have to manage, and sort of a structured data, highly relational type scheme works very well in a lot of cases because the world is very relational, but it's also super fluid. And when you start getting into trying to architect really relational systems, you start running into problems when you're trying to present relevant data to your client. So you really have to think about trying to optimize and use that balancing act to try and get the data processing that you want to do more pushed off on the clients and less on the server side, and then use the size of your pipe to sort of make that decision whether or not, in this particular instance, with this piece of content, how much processing is my server going to do, how much data am I actually going to be sending through my pipe, and then how much processing can I expect the client machine to be able to do. So this optimization balancing act and this caching low-hanging fruit are sort of the directions we want to go. So with Drupal, I was talking before about how it's very, very relational on the back end. It relies on a SQL database. And Drupal itself has this concept of that's pretty much every Drupal site uses it. It's called views. And the content creators and the content authors and the site visitors can go in and architect a view very easily. It's fairly highly abstracted. And they can get reports of pretty decent size fairly quickly. The problem is when you get too relational and you have too much data to sort of expunge out of your system, like Diana was saying, Drupal falls down. So we developed a site for NRG Sunlease, and they basically put solar panels on people's roofs, and it's a quote generation machine. We built them an application that allows them to sort of view a situation and go, well, let's generate a quote for how much this is going to cost. And I think Andrew can probably explain their business model a little bit, and then I will jump into sort of how this relates to Drupal.
So as Sam was saying, they generate quotes for people, and these quotes are actually kind of complicated because it involves the angle of the roof, where they are in the country, how much sunlight they get over the year, what is the cost of utilities for their zip code. There's all these different variables and parameters that go into what they estimate the lease is going to be. And they want to extract business intelligence out of this process, and determine after sampling how closely their estimates were to reality, and they want to measure all of these details based on the equipment and how it performed in a particular location, and they can use that to then assess new markets, whether or not they want to try and lease solar panels in Kansas or in Colorado, or something like that. So the quote generation was one part of it, but the reporting was a huge component, and just a whole lot of metadata associated with these quotes that they need to pull in and perform this business analysis on. And it was originally, the reports were built using views because it's very, very fast to click, 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 pull together this report. There you go, functionality delivered. The problem is views has a lot of overhead because it's an object-oriented system. It also, the queries that it does produce aren't going to be the most efficient. And this particular report was so big and so heavy, it would take on the order of minutes in order to pull in data, which was unsatisfactory.
So with Drupal, we sort of have this sequence, and I was talking about low-hanging fruit earlier, and that's important in your solution architecture because you don't want to do more work than you have to. So with Drupal, it sort of has this standard where you kind of start out with views, and you go, okay, yeah, it's working really, really well, and then, like Andrew's saying, you get reports that take on the order of minutes to generate. So that's an example of some code that actually comes straight out of views. And I don't know if you guys know much SQL, but you can see it's just join, 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 right? In other words, SQL, right? So the sort of next step in the evolution of trying to optimize the next set of low-hanging fruit is the Query Builder API. It's an abstracted object-oriented system that's built into Drupal, and it allows you to dynamically generate queries, and so you can make smarter queries based on what you're asking for. You can do conditional logic, and the nice thing is that the Query Builder API ties directly in to Drupal's theming, so it's dynamic, extensible, and integrated directly into Drupal. You can write your own extenders. Some default ones, there's a pager by default, and there's a table, table sort, and all these types of things that are built directly into Drupal, tie in with Drupal's theming layer. So it's really nice because you don't have to leave Drupal. You don't have to do anything else to get this to work. This is exactly what we did on NRG. We had reports that were running a couple of minutes. We reached for the next set of low-hanging fruit. Turned out the Query Builder API was able to get those reports down to a couple seconds. And so that's really where you're headed with solution architecture in Drupal. The next set of low-hanging fruit, if you still need more performance, would be to jump into just writing static SQL queries, right? I have a little bit of experience with this, but not in the sense that you would think this is a good thing. The first web application that I really ever built, and I just sort of my first dive in to try to build a web application, I built a database system to track students at a university who were attending concerts. So they would go swipe their card, and it would say, oh, you've signed in, and then they go to the concert, and then they swipe their card, oh, you've signed out, and then we can basically say, oh, you attended 6 concerts or 10 concerts this year or whatever. I built the first iteration of that application. I built completely in PHP with string manipulation of raw SQL queries. My code was sets of giant if statements nested 5 layers deep. And at one point, there was one query that if you wanted a certain report, I would have to go into the code and add a parenthesis. And then if they wanted the other report, I'd have to go in and take that out. So it was just a nightmare, a spaghetti code nightmare. And that was my first sort of like trial by fire, like, oh crap, this is not the way to build a web application. So going with static queries, the point of that is going with static queries, eventually somebody's going to come to you and say, I want this report, and you're going to go, that's going to take me 2 weeks to write a static query that's going to be able to do that for you. So you're at the end of your rope, right? The set of things, the set of low-hanging fruit you can reach for in Drupal has been completely exhausted. You need more performance. What do? The answer happens to lie in what I like to call co-SQL. There's probably a lot of different chat at this conference about NoSQL, and I actually don't like that term because it sort of means don't ever use SQL. I like co-SQL better, and actually NoSQL is more like not only SQL. The reason is, like I was saying before, the world is highly relational, but it's also highly fluid at the same time. So why not have a database backend that does that, has highly relational and super fluid at the same time? So what we decided to do was layer the backend of Drupal with a NoSQL option. We went with MongoDB for various reasons. And what we ended up doing was actually duplicating the data that was coming into MySQL in MongoDB. And then our data miners hit the MongoDB database, and our content creators write into the SQL database. Now, there's certain issues when you go with NoSQL, right? Chief among them, the CAP theorem, right? So now we've introduced this complexity where we're duplicating data, and that calls into question the integrity of that data. And so what you have to decide, what you have to balance in a situation like this is consistency, availability, and partition tolerance. Traditional relational database management systems fall in the consistency and availability categories. But MongoDB falls in the availability and partition tolerance with eventual consistency. So what we're trying to capture here is trends, right? So MongoDB is flat, no relational things whatsoever. It's just one giant table, and you put documents into it. This allows you to get reports out very quickly, but they might not be exactly perfectly consistent and have perfect data in them. But that's okay for certain types of data. So the reason we had to do this is for a company called First Crush Tastings, and I'll let Andrew sort of explain that one to you.
Okay. So First Crush manages and coordinates beverage tastings in all the grocery stores in all of Texas, everything from H-E-B down to your mom and pop store. Their clients are people like Anheuser-Busch, Mike's Hard Lemonade, Gallo Wines, large beverage suppliers. So the application that we built was in order to help automate their process, because they were originally running on spreadsheets, trying to coordinate all the different people who are running tastings on a daily basis. And so we built them a scheduling application so they could create jobs. All of their army of ambassadors could sign up for them, be like, yeah, I'm going to do that one, I'll do that one. And then after they're done with the tasting, they fill out a survey and a report about how it went and provide some data. So those are the users of the system that are creating the jobs and then creating the data about the jobs. Their clients, though, the suppliers, the beverage suppliers, they want to aggregate all the metadata about these tastings that have happened and basically they want this. They want to report on all the different sales metrics, how many jobs were performed, the impressions, the interest, the awareness, how much was sold, what was their highest grossing day for HEB in Kyle, or what was their best-selling product at HEB, something like that. So they want to be able to slice and dice this data very quickly. So we didn't want to go the views route, and at the time, Query Builder wasn't available for this version of Drupal. And static queries, like we mentioned, there's that trade-off between a higher level of abstraction and performance. So as you go towards static queries, towards a more performance solution, you lose some of the maintainability that you get from a higher level of abstraction. So that's why we decided to go with Mongo and duplicate the data, because with Mongo, it was really easy to write these queries. These queries are dead simple in Mongo because it's no longer trying to join everything and coordinate it. Now it's just, you just have a series of documents, and you can index that and query that very, very quickly. So we gain back some of the maintainability from a higher level of abstraction, but maintain the performance that we get from a lower level of abstraction, like a static query.
So in this session, we really want to talk about what we do on the front end. So last session, we were talking about the back end. And on the front end, it pretty much involves trying to bypass Drupal, believe it or not. And so you really want to ask yourself about solution architecture up front. And you want to say, do I need Drupal? And we are of the opinion that in most cases, when you have a customer who needs to manage content along with some data analysis, that Drupal is a good answer. It has so much out of the box for access control and content creation and content management that to write that yourself would just take too long, and Drupal's fairly good at it. So we love that it's a rapid development platform. It works great in a lot of these cases where you need to manage content, and then you can just add on to it and extend it when you need really good reporting. So we're going to talk about the cost of Bootstrap. Drupal, one of its brilliant things is that it relies on hooks, so i.e. Captain Hook. Drupal is, in fact, Captain Hook. What I mean by that is Drupal itself has the idea of contributed modules. So you get core functionality, but then the entire community of developers write individual modules that use these hooks to extend Drupal itself. And what Drupal does every time you ask it for something, it goes through a process called Bootstrap, where it basically looks at all of the lists, the entire list of all of the modules that it has enabled, and it asks, do you have code to contribute? Do you have code to run? Do you have data to process? Anything. And it goes one by one and just asks for this extra functionality. And this is actually really common in most PHP, MySQL sort of applications, where you're using what's called a front controller pattern. You have a single entry point to your application, usually index.php, right? Index.php is hit every time you type in a URL. It doesn't matter what the URL is. And in essence, the URL itself becomes your command line interface to the entire application via this front controller index portal. And that's exactly what Drupal does. Every single request hits index.php, and then Drupal bootstraps and says, all of my modules, what code is relevant, I'm going to run all this code. So that's what really makes Drupal a rapid development platform. You really can just sit down and build something in an afternoon that's fairly complex. What's the problem with this? Why is the bootstrap such an issue? Because of this. So imagine you have 100 modules and you add one more. Now your backend becomes more relational because that module may have its own custom table and its own custom schema, and it may be storing data in this really bizarre way that only it knows about. And so you end up with massive, massive call stacks. Every time you hit index.php, you ask Drupal to run every piece of code that it can run, and then you have to reload the page. So you can imagine if you had to do something in real time, that this would not be a good situation. Bootstrap on every request. So the example that we use to illustrate this problem is autocomplete fields. So Google, you start typing and it just gives you suggestions, right? In the Drupal world, this is built-in functionality. The problem is it's hitting the Drupal bootstrap every time you lift your finger off the keyboard. It's running all of that contributed code. And so it just is unmanageable and completely slow. So what do? Well, you try to sidestep Drupal. Basically, you try to avoid the Drupal bootstrap. You let Drupal do what it's good at in content creation and content management and access control and these types of things. And then you use other technologies like non-relational databases and front-end application software that I will let Andrew go into detail on to come up with a solution architecture that looks like this. So your content creators are still going to use core Drupal. They're going to log in, they're going to create interesting content, they're going to give you your data, and Drupal itself will be your entry point for collecting that data. But the users who you're actually selling the product to, your data miners, they're not going to use Drupal at all. It's going to look like they're using Drupal, and you can use Drupal to create the pretty HTML and the wonderful theme and all that sort of thing. But what they're really going to be doing is hitting a front-end application stack. And I'll let Andrew go into detail about that.
Yeah, so by letting Drupal deliver a front-end application, and this would be what we would call a single-page application, where it's just a bunch of JavaScript. So think Gmail or something like that, where you're not making a bunch of different page requests as you're interacting with the application. Instead, the application dynamically loads what it needs on the fly. So by building this single-page web app and having Drupal deliver that, you only have one bootstrap, the initial page load. It delivers the application to the browser, and from there on, the browser does the rest of the work, pulling stuff that it needs. So in this case, we've optimized our back-end data store. So we have a really, really fast MongoDB data store that we can pull data out of. We want to sidestep the Drupal bootstrap. So we're going to build a lightweight API that will expose the data from that we have stored in there and shuttle it over to the browser. So not the server, to the browser. So we're if you remember in the first session, we talked about this balancing act between how much processing you do on the server, how much data you're having to pass over the pipe, and how much work can be done on the client. This is part of that equation, figuring out what you're going to do. Now, also imagine for a minute that we have external sources that we want to integrate on this site. And maybe it's even real-time data, in which case you definitely do not want to be tunneling that into the Drupal bootstrap, because that's going to introduce a whole bunch of slowness to what should be real-time. So we're going to build an API. And I like to build these APIs in Node. You can do it in anything. There's a similar type of framework in every language out there. So you can pick one that works for you. I like Node, though, because from the very inception of it, it was an asynchronous, non-blocking framework. And so all of the modules, all of the ecosystem around it was built with that in mind. Whereas these other frameworks live in an ecosystem that did not come from that world, and so there's fewer modules and things like that. But we're just building a lightweight API, so probably any of these would work. We have to build this API for two reasons. One, avoiding the bootstrap, but two, if we're going to be integrating external sources, there's a limitation that the browser imposes on JavaScript code. It says, oh, you can only make requests from the same domain that this page has been delivered from. So if you're making a call to your domain, then everything's fine. The browser says, oh, yep, that's okay. If you want to make a call out to an external resource, they have to enable what's called cross-origin resource sharing, or CORS for short. And if they have that enabled, then your browser will send an option request, and that server will respond, yep, I will share data with you. The browser says, great, get me that data, and you get the data. If this external data source that you want to integrate with does not implement cross-origin resource sharing, you have to proxy that data. So that's why you build an API. You can pull your own data, and you can proxy external data sources. Now, it's a good idea. I recommend, if you're not doing real-time stuff, then build your API in a RESTful way. And there's a link on there to Apogee, which has some really good documents on API best practices. And yes, they do have a product that they are selling, but their documentation about how to build an API and some of the conventions to follow is very excellent. Okay, so now let's get into a little bit of the nuts and bolts of constructing this API. First, you need to pick a framework. So Node is the low-level platform. It's very, very low-level networking type framework, and you're going to want something on top of that to make it easier to build these APIs. There's two I can recommend: Express, which is more for actual web applications, and Restify, which is focused on strictly being building REST APIs. I'll use Express as an example in some of the code up here, but I recommend either. Okay, so we'll go with Express. Now we also need to pick what we're going to use to connect to our Mongo backend. There's quite a few out there. I like Mongoose, but Mongoose is pretty big. It's a very full-featured object relational mapper library. There are some lighter weight alternatives, which are also really good. So you just have to ask yourself, how much abstraction do you want in front of MongoDB? Do you want to be writing the Mongo queries the way you would in the shell, or do you want to be working with an object and just call find on that object and it gets you what you want? Okay, so in the example that I'm going to show will be Express and using Mongoose. So with Mongoose, we connect to the database. And then after you've established a connection, you define your models, basically, the schemas. So here I've defined one that has two fields on it, some field, which is a string, and another field, which is a number. I then create a resource, and I say, hey, this resource equals this model. And so now, for the rest of the code, I will be dealing with app.resource, and I can run methods on that object, and it will collect the data or insert data into Mongo based on that. Okay, so it's an API, so let's create an endpoint. And it's going to be, this endpoint is going to be your domain / resources. So we're doing a GET request on a resource, or actually all resources. And all I do is I say app.resource find, and that runs a find on Mongo, and it gets all of the objects, all of the resources. And then I just say response.send that resource, and that's what I get, right? I'm going to get some JSON back with an array of all of the objects in Mongo with a string and number field. So it's really easy to very quickly build out a lightweight API to your data using Mongo and Node. It's very simple, and it's very fast and very performant. All right, so now we want to actually consume this data, and we're going to be consuming it in the browser. Right, so we've got our external sources. We've got our own Mongo database. We've built an API. We can now shuttle this data in a very fast and efficient way. to some sort of front-end application. Basically, it's just going to be JavaScript code that calls our API. But wait a minute, isn't JavaScript slow? Yes, it is. However, the JavaScript interpreters are getting faster all the time. The devices and whatever's running the browsers are also getting faster all the time. And because we have optimized the data processing, so we've minimized that, and because we've skipped the bootstrap, we've reduced the overall round-trip time that data is going to take. We're not sending fully processed data that's all marked up in one big page load. Instead, we're just serving up little bits of data as the application needs it. And so that actually buys us a lot of time. So even though client-side rendering of a template is slower than the server spitting out HTML and sending it, because we've reduced the round-trip time, we've actually gained enough that it still ends up being faster. Okay, it's very important to organize your code, right? You could just make a bunch of jQuery AJAX calls to your data, but as soon as your application needs state or a lot of user interactivity, your code will get convoluted very quickly in a mess of AJAX callbacks and DOM manipulation. So use a front-end framework. There are lots to choose from. A new one probably came out this morning. Two that we like are Ember and Backbone. Backbone's been around for a long time. It's really lightweight. It's great. But Ember is one that I'm really excited about because, well, it strikes a good balance between being lightweight and being very, very full-featured. So it handles the garbage collections of your views. It gives you lots of different tools for manipulating and managing data. There's a really good write-up by Evil Trout on why Discourse uses Ember, which I throw a link on there to look at. And after we post these slides, you can look up some of these other resources about what's great about Ember. So we're currently using this, building out an application for algebraic data. And I don't know, Joe, do you want to mention what you guys do?
Joe, can we put you on the spot to explain what your company does? Okay. Come be on the video.
So algebraic data has contracted with Astonish Design to build an application around injecting semantic markup and tagging into customer sites for products to get rich snippets like this in Google search results. They're doing the customer data management, billing, and ultimately handling analytics as well via the Google APIs. So we are providing a Node.js API to pass data back and forth. It's all based on JSON, JavaScript data. And Mongo is kind of the middleman that stores intermediate results and big JSON documents. But the idea here is that we can take any arbitrary website, parse its DOM model, and then attach markup to the DOM model to generate rich snippets independent of your content management system, independent of your back-end database. We don't have to install anything. It just rewrites it on the fly in the browser using JavaScript. So that's very attractive to people who don't want to learn the whole semantic web stuff, don't want to learn all the new Google rules that change every month. We can just provide a service, software as a service on the web to do this for them. And we're launching that, actually our first customers due on Monday. So this is really new stuff. We've got it all tested. Most of our backend is on Amazon's cloud. We don't host anything locally. It's all on the cloud. Everything talks via an API back The Drupal is the customer portal. It manages the customer data. We just throw up markup on demand. That's the thing we're trying to do. So far it's been working pretty well. We think we can scale using a content delivery network. Amazon's CloudFront lets us host the JavaScript that we're using to do the injection, and we can also inject the customer data out to the edges of the network. So the actual load times are about 50 milliseconds to get, when the user grabs a page, they get the JavaScript and it rewrites the page in about 50 milliseconds. Which that's passable. I mean, people don't even notice that. So that's our latest, that's the results as of Friday. So hot off the presses. Thanks.
Joe.
Thank you. And stay tuned for more as the application matures. We're going to keep writing about it, too, what we're doing with it.
Yeah. So the thing is, they have this huge process that crawls these sites and figures out where it's going to inject the snippets and all that kind of stuff. And so all of this data is external to the Drupal app. So why run it through Drupal? Instead, let's build a front-end application that talks to their API and interacts with their API, which is what we did, what we are doing in the process of. So to give you an idea of a small sample of how Ember makes this really nice, I'll give you an example of form validation, for example. So when you first go to the app and you haven't defined any sites for algebraics to analyze, you get this little modal that pops up and says, hey, add a new site to our service. And if you start typing into the URL field, we validate whether or not it's a fully qualified domain name. And if it's not, we send error signals, error coloring around that field. How Ember makes this easy is that it already out of the box has this idea of properties and observers of those properties. And if you follow the conventions, everything just links up. So in the controller, I can declare a method that's going to get called anytime the URL changes, because you'll see at the bottom, it observes the content.url. And if it's not passing the validation, then I can set another property on the controller called isURLValid. I can set it to false or to true. Well, in the template, I just say, hey, bind the class attribute to isURLValid. And if it evaluates to true, don't do anything. If it evaluates to false, then print error as the class. And that's all that you have to do in order to wire that up, because Ember just gives that to you out of the box as a part of the framework. So that's how we optimize data for data miners that are interacting with a Drupal application, but need their data in a faster way. We optimize the backend, store things in MongoDB, build a lightweight API, and shuttle it up to a front-end application.
So this is going to beg the most essential question, I think, that comes out of the two sessions, and it is the question we got a version of in the first session that I put off until now. And the question at that time was, did you consider other applications as the middleware, so be it, of this? And so why use Drupal? If we're talking about denormalized data or data from other kinds of sources, and we're talking about using a framework in the middle to act as an API, and then we're delivering the content through a front-end framework, why use Drupal? And so our answer to that question is, don't use Drupal if you don't need it. Like, there's this architecture that we are suggesting and that we have been implementing is based on the fact that these web applications have a fundamental use case that includes some necessity for content management. And once we start having to custom code content management processes, now we're going to lose what we save by layering on top of a content management system, right? So if I left Drupal out of this, and then later, so let me give you an example. So let's say we have a sporting event that wants to be able to publish information, publish results of a sporting of the game, right? To give you scores, different kinds of scores, right? I don't need Drupal in the middle. I can bring that in the way, kind of the ways that we're describing here. We can bring that data in from an external source and present it without the bulky in between of a PHP application. But then the client says, I want to be able to blog about and publish articles related to this game. And I want to do news updates about what's happening. And then in between the games, I want to talk about the players. Well, now, if I have to write that code by hand to add it to the framework, now I'm going to add bulk to the layers as opposed to enhance the CMS. So, but that does not mean, and we certainly don't, and the team more often than than maybe I'm necessarily comfortable with suggests not using Drupal and looking into other technologies. And so we do try and balance those particular needs when we're doing solution architecture. So there's one other thing that if you come from a CMS world, and if you come from the Drupal world specifically, that this kind of architecture, application architecture, changes. And I can tell you that we are not at all the only people that are doing and building by integrating these kinds of applications. This is becoming more and more common. If you look at DrupalCon Portland, is coming up in May, I want to say May 19th, May 21st. And here's where I do a little plug for the fact that if you don't know how to code PHP and you want to learn, come to Portland and we'll teach you. But there are also other trainings that are going to be offered, and training in Node.js and how to build. Actually, in the earlier session, one of the trainers was here in the session who's going to go to Portland and teach people in the Drupal world how to build on Node.js. So, there are going to be a number of sessions on denormalized back-end data. So this is a conversation that's happening in the Drupal sphere. But a very traditional role in the Drupal sphere is the role of the themer. Right? So 3 years ago, when I hired, I tended to talk about back-end versus front-end. Are you a back-end developer or are you a front-end developer? And then I started to use the word hybrid. I'm looking for a hybrid. Now I can tell you that the skill set is, here's an empty server box. Can you install a LAMP stack, put some DevOps workflow in it, pick a version control system, but it's probably Git, because that's what we use. Install layers of applications, write the code that makes them go, and make it look good. Can you do all those things? Because that's what web application development is becoming. Now, so all of us have, my skill set tends to be coding up through JavaScript, but not necessarily custom JavaScript. I can do it, but I don't like it, so I don't do it, right? And then we have people whose skill set shifts very much to the front, design, user experience. They can implement HTML, CSS, a little bit of jQuery, some PHP, if else, right? So Andrew and Sam, empty box, just give them empty box, and then things get built and go, everything you need. And we'll fuss a little bit when it comes to the CSS cross-browser compatibility testing, right? So everybody's skill set is going to be different, but it's expanding. But in the CMS world and in the Drupal world, they are a career path, right? They're a profession. And this kind of layering is challenging that. And so the word that I borrow from Chris Ruppel calls himself a front engineer. And that, I think, is a great summation of what's happening to the front-end skill set that used to be HTML and CSS and jQuery, and is beginning to expand. But it's also happening for back-end developers that you needed to be able to get in, you needed to be able to handle the command line, be able to do things in the command line, set up the LAMP stack, do some, server tweaking when you needed to do that, and then write PHP code, optimize SQL queries, those kinds of things to hand that off to a themer. But now JavaScript, coding in JavaScript is becoming essential to the back-end developer role as well. So I think over the next 2 years, you'll definitely see the skills.